back in the shop this evening. Going to use an Altoids tin and some potentiometers to make a high range variable resistor for circuit bending purposes. Sometimes when I get into something I'm working on and I find out I need a resistor, I think, oh, I'll just grab a potentiometer and I can dial in where I think I want to be, and if it's something that needs to be fixed, put a fixed value in there, or put a potentiometer in there. But sometimes the issue is you can't get fine-tuned enough, and you have to solder multiple things in there before you can figure it out. So to alleviate that issue, we're going to do a range of potentiometers. These are all linear, I believe, not the logarithmic. So these are all linear taper potentiometers. This is what I have. But we're going to do from 500K, 150K, 10K, 1K. That should give us a pretty good range of resistances. And they all go from 0 to their top end. So, and then we can estimate roughly what resistance we're using on whatever circuit. So my plan is to get it into an Altoids tin, but I wanted to kind of dress it up a little bit. Anytime I make stuff with Altoids tins, it always ends up just looking like a boring Altoids tin. So this time I have plans to dress it up. So I took some plastic, cut it up into chunks, and if you take a parchment paper and an ironing or a clothes iron, you can actually make these nice sheets of plastic, and they melt together really nice, and they're kind of colorful and fun, and it's just something different. But I've sized it pretty close to. It's not gonna be perfect, but should be just a little bit more interesting than a normal Altoids tin. So, first things first is to drill the holes, but I already did that earlier. So, drilled some holes. They're close enough. They're not gonna be perfect, but I am not looking for perfection. I am looking for good enough to get the job done. So, but we do need to finish the job because the plastic needs the holes in it. I think I'm using a 5/16 drill bit. That's what I had that was gonna be large enough to let through the threaded end. They might have a little bit of slop in them, but I think it'll be alright. Well, let me see. Maybe I have something a little better. Let's see, 5/16. Maybe I'll try a 1/4 inch and see if that's big enough for the plastic. I don't think I dare freehand these. We'll do that off camera. Spare you. I got the holes drilled. Made a lot of microplastics. I'm sure that'll be great. These little tabs are going to be in the way. Normally they're great for biting into soft plastics or wood, but for my purposes, I do not need them. So I'll just snap these all off. 10K. 1K. Orientation on this side doesn't matter. They're circles, so it's going to be all the same for either side. I'll get the hardware put on these and be right back. Alright, that went pretty well. Noticing now that I have everything tightened down, this was not cut exactly correct, and part of it's because the plastic delaminates. Some mismatched plastics going on in there, but overall I think it looks pretty good. Didn't use glue or anything. I figured it would kind of hold itself down, and seems to be held down pretty well. I might Might sneak some glue under there just to make sure that it stays down well, but pretty happy with how that looks. I guess I could take the iron and kind of smooth out the edges, maybe kind of melt it over the sides. That might look kind of nice. Anyway, the inside. This is what I got in here. So it goes 1K, 10K, 50, 100, 500K. Just mark that so I wouldn't forget, because it looks the same from the top. So if we think about how we were wanting to turn these, I want to make it so all the way counterclockwise is 0, and all the way to the right is the maximum amount of resistance for each potentiometer. So to do that, if you're not familiar with potentiometers, so this middle lead is for the wiper, and basically whenever you turn that knob, it goes back and forth. These are either side of the resistive material that is in a ring around the whole potentiometer. So if I were just to connect these two up onto this particular potentiometer, I would get out 1K ohms no matter where I put the position of this. That's because the wiper wouldn't be in effect. If you actually want to have the wiper in effect, you have to hook up the middle and one of the other sides. So because I want the resistance to increase when I turn it clockwise, we are going to, so this would be, these two are closest to each other. The wiper is close to this side. We have 0 resistance, and max out by turning that way is the max. So, and this is going to be the same for every single one. So I'll just make it really easy for myself to remember that by bending up that resistor leg. And that's out of the way. And I'll do that with all these other ones. I have all the legs bent up on the left side of each potentiometer. I'm thinking I want this side to be the, we'll call it business end, where the wires are coming out to go to whatever circuit bent device we're working with. So, let's see. Wire path I'm thinking I'm going to follow is from here to this guy, from here to this one, from this one to this one, from this one to this one, and the two leads that go out to the circuit bent device will go this way. And that'll put every single one of these potentiometers in series with whatever resistance I put on it. As far as wire, I have this solid core wire. Probably just estimate these wire lengths. Wire's cheap, we'll try it out. This solid core bell wire is fine to have in the inside of the device, but on the outside we're going to want something with stranded core wire, a little bit more flexible. And for that, I have this stuff, which I harvested from, I think it was like some kind of network cable or like a VGA cable. Anything with a ton of pins on it will have a bunch of colored wires. It's really handy when you're circuit bending, because sometimes things get pretty crazy. And this one happens to have copper conductors. This is pretty good stuff, actually. Doesn't come off just with your fingernails as well, and I don't recommend using your teeth either. But a small pair of scissors, or maybe proper wire cutters if your money bags. So now we'll take these wires, make sure both ends are stripped. Don't need a ton here. Yeah, I love how fast this bell wire strips. And of course now it's giving me trouble. It strips better when it's cold. Maybe if your workshop's not like, 95 degrees, work a little bit better. safety glasses. Gotta put those on. Don't want to fling molten solder in your eye. Hasn't happened to me yet, but I'm sure the day that I don't wear my safety glasses is the day it'll happen. Gotta stay safe out there, you know? Downside of this solid core wire is I can feel it get hot pretty quick through that very thin insulation, so just gotta be careful with that. Have some tweezers somewhere, probably be good use for that. There we go. And that kind of holds on to heat for a second. And I used way too much wire, but nothing a little bending can't fix. Alright, so now all of the potentiometers are wired in series with each other. And I just need to get this lead and this lead, some holes going through out, and it'll be done. So let's pick some fun colors of wire. We're doing blue and white, and it's a fairly long piece, so I can have it out of the way. But also this wire is going to be slightly consumable. That's something I can change later on if I need to. So it's actually going to be soldered to bend points temporarily with just a tiny little bit of solder. And this will be out of the way so I can work on the project. And yeah, we'll get these stripped and soldered in. Let's see. Let's be the business end. Let's have them come out here. And we'll give it a little bit of coil inside so it has space to open in case we want to add any other modifications at a later date. Okay, so now if I did that alright, this should be able to pretty much close. Doesn't have to be perfect. Now we have our nearly completed thing. Just need to get these guys on, and we'll be right back. Alright, it's looking pretty nice. These all on their lowest settings. Oh, I need to get some hot glue in there still. I don't know how I feel about these rechargeable hot glue guns. They kind of work. This one in particular doesn't really bite into the hot glue, but it was on sale. It only cost me $5. Alright, so got the ends soldered up to a couple of bend points. I'm trying on this speak and read. See if I can't flip it over. They are just, just barely tacked on. Batteries have been falling out of this thing, so and test it. So it looks like a small amount of resistance will crash it. So this is the 500K. Let's try the 100K about halfway. Try to get it as low as we can. So join the bottom end of that, so I think we need to be using something smaller. So let's try, this should be the 10. Let's do the 10 about halfway. Still too low. No, reset it just in case. It's also possible my batteries are coming out. Nope, I think they're okay. But basically you can use this to dial in stuff. Because if we max these all out. Interesting.
Which word? Press the letters. What is?
Well, this thing's doing its job. This is just,
Which word?
I don't know what I'm doing with this thing, so. Connection's held up though, so that's good. That's all I got for now though. I might iron this down so it's just looks a little bit nicer. Maybe a little bit more melty and not lifting up. Maybe I'll put some glue into there, but that's all I got.